Hello and welcome to djtutorials Primers. This will be the first in a series covering technical knowledge about probably the most important part of starting to become a CGI and or digital artist, which is your computer. I'll be going over in detail a bit more than perhaps you might think you need, but as a consumer and as a professional, you should probably take every part of your artistic process seriously and fully understand what you are buying and why. Just like a painter will need to understand and appreciate the difference between mediums, brush types, manufacturers of paints, canvas types, pigments, we need to understand the basic computer needs, what they do, and why they are important so that we understand and appreciate how we create our digital art. In this series, I will be covering a brief explanation of what the computer parts or components do, discuss the positives and drawbacks of tower or desktop computers versus laptops and tablets, my view on the Apple versus PC controversy in manufacturing and operating systems, and finally, my recommendations for what kind of computer you should buy. Since this channel is dedicated toward people who are looking to do everything in digital production, from 3D asset creation to compositing and editing, I will be focusing on builds and recommendations for that particular demographic. The main software that we'll be looking at for our computer build will be Blender, an open source and free 3D animation and visual effects creation software available to everyone. This software is rather demanding as you build complex models and renders, so it is a good software to focus around for our computer needs, as it will help in other software as well, like GIMP, Inkscape, DaVinci Resolve, and Natron, which are also open source programs available for free to you, and the Adobe Suite. So if we go over to the blender.org website, we can actually take a look at what the requirements are for this software to run. To get there, all we have to do is go over here to download, and then up at the top in this little ribbon here, you'll see requirements. So if I click on that, you'll go to a page that will be a lot like if you're looking at a video game or other kinds of software. It will tell you what it's recommending that you have inside of your system. The big part that I want to focus on with this video right here is the hardware requirements. So here it says that the minimum requirements are all of this stuff here. The only thing you need to worry about is if your computer is less than 10 years old. Pretty much that's the only thing I would say really matters. And very easily you can just download the Blender software, install it, and see if it works. And if it works, it'll work on your computer. So if that works, then that's what the minimum requirements are. But we're going to be focusing more on these recommended and optimal requirements for your hardware or components so that you can use this system to make some really, really great pieces for your portfolio and to become a professional. Although the most important component to the computer is most likely the motherboard, which is a component everything is attached to, I will be covering that last since you really should know what the other components are that connect to it. So to start with, we're going to be talking about the CPU, or the central processing unit. The CPU is kind of like the brain of your system. It basically handles the calculations and tasks of your computer and in some ways controls the other components, operating system, and software in your computer. The CPU has what are called cores. And if we look at a lot of these different products on the AMD page, these are the Ryzen processors here, we can see that there's a couple of some basic stats. So here we can see up to 16 cores. Well, what does that mean? A core is basically the number of processor cores, and it's where the processing happens. So you may have heard terms like quad core, hexacore, octa-core before, and that just means 4, 6, or 8 cores. And generally speaking, the more cores, the more efficient it is at doing computations. Now, remember that I said in most cases because there are some caveats to that. You may have also heard something called hyperthreading before. So, before I talk about the hyperthreading, I just want to talk to you about what a thread is. Basically, a thread means how many sort of like calculations a core can do. So, if you have a non hyperthreaded processor, then you would have a 1-to-1 ratio of the number of cores to the number of threads. So, if this happened to be a non hyperthreaded CPU, then you would expect to see 16 cores and 16 threads. But if we look right here, we can see that it says up to 16 cores and up to 32 processing threads. So that means that this is a hyper-threaded CPU, meaning that each core can handle two processing operations at a time, which is great because it basically doubles the amount of work that our CPU can do when we're doing renders or we're working on video and caches and stuff like that. The next thing that we're going to talk about is the frequency, which is basically the speed at which your CPU is going to be running. Now, if we look down here at the bottom of this page, it will tell us the number of CPU cores, the number of threads, and then it talks about the max boost clock and the base clock. Well, what is that? This is basically the frequency of your CPU. It's how fast it is. So the base clock means that all of these CPUs will be expected to run at around 3.5 gigahertz under load. The max boost clock means that if it's under a heavy load, at least one of your CPU cores are going to be running at this speed. Now remember I said one, okay? So if you're monitoring a render or anything like that and you're seeing that some of your cores are not at the 4.7 gigahertz, it's because that's just the max boost clock for one or a few of the CPU cores. They won't all run at this, so just keep that in mind when you're looking to purchase. If we look at a comparable CPU to some of these Ryzen desktop CPUs, such as the 9900KS here, it's kind of hard to see this because the background's kind of crazy on this ad, but the 9900KS, which is an update from the 9900K, which I actually had previously, we can look down here and we can see number of cores, so performance, number of cores is 8, number of threads is 16. Processor base is 4, and the max turbo is a whole 5 gigahertz. So that's a bit faster than this one here. It's 0.3 gigahertz faster than this 3950X. And it's even more faster than the 3900X, which has 12. So this processor is faster in general with a processor base frequency for all of its cores, and its max turbo frequency is at 5, which means that at least one of these cores is going to be running at that speed. So why would you want this over something like this? Well, it really depends. And to make this a little bit more comparable, let's look at a Ryzen that has 8 cores and 16 threads, which will be more comparable to the KS. So let's go back. So if we look here, we can see that even this 3800X, which is the much more expensive version of this processor, it only gets up to 4.5, and the base clock is a 3.9. So it can't quite match the speed of the 9900KS. And if you are a person who is going to be using primarily single threaded operations or single core operations with a single thread, like Photoshop, for example, if that's your main uh, program that you're going to be using, then this would be preferable as long as you think the price point is okay with you, because it runs faster at a single thread. And if you're not using multi-threaded operations like Blender or render engines for video or things like that, then really what you want is a faster single core speed. You do not really need a whole bunch of threads to run Photoshop. So if you were going to compare this version to this version or these two CPUs, this one would be preferable because of the higher rate. So I hope that makes sense to you guys. If I jump back here and we look at, let's look at something crazy. Let's look at the 3970, the 3960X here, which is much more of a high-end processor. This has 24 cores and 48 threads. So obviously, if you want a CPU, I actually have this CPU. If you want a CPU that does really fast renders because of the number of cores and threads, this is what you want to go for if you can afford it. Because what you're getting here is a lot more processing power. than you are with the 9900KS, which only has 8 cores and 16 threads. But if you're only running Photoshop, this is, sorry, this one here is complete overkill. There is no need to have this. So those of you who are just going to be doing Paint and things like that in Photoshop as your primary way of doing digital art, this is completely unnecessary for you, and you should not be looking at something like this. But for the people in this channel, hopefully you're not only going to be doing Photoshop. I will tell you that I did have the 9900K, and it worked just fine for a couple years for doing 3D animations and things like that. I just moved out of this, but this is a decent one if you can afford it. It is a starting price of $700. So if that makes sense to you, fine. Now, let's also take a look at something called TDP, which is the wattage needed or the amount of power needed to run this processor. So we can see right here for this particular processor, you need 127 watts, and that's pretty high for an 8-core 16 thread. And most of that has to do with this right here, the speed at which it's running. There's also one other thing that has to do with the actual size of the transistors, but I'm not going to talk about that in this video. So if we look at the Ryzen 7 and we look at this, let's see here, the 3700, yes, the 3700X here. You can see there's 8 cores, 16 threads. 4.4, yeah, it's not as high as the 5, and the base clock isn't as high as the 4 on the 9900KS. But look at this right here, 65 watts. You're looking at half the processing power needed to run this 8-core, 16-thread CPU. And this is much less expensive. Um, let's see here, 3700X price, 329. So the 3700X is around $320, whereas the KS is a whopping 700. So if these differences are worth it to you, that's the kind of thing you want to go with. Otherwise, this 8-core 16-thread is a much more budget-friendly choice, and you will be able to run Blender and other render softwares just fine with using this 8-core 16-thread system, and then you'll have a much less power draw to your system. The last thing I'm going to go into is, and I'm going to do this very briefly, it has to do with what's called the PCI Express lanes. And you can see here it says 16. So because you probably don't know what this doesn't make any sense to you. All you really need to know is that all this refers to is the number of extra peripherals you can plug into your PCIe slots on your motherboard, which we'll go into when we talk about motherboards and all that. 16 isn't very much, but it's very good for a single GPU system. And if you're not plugging in too many solid state drives directly into your motherboard, which I'll talk about later, just know that if you plan on running a higher GPU system, you will run into efficiency problems. It's not too bad. You can still have a multi GPU setup. I had 3 in my previous build running off of 16 lanes, but your GPUs will not be running as efficiently as they could be. So just keep that in mind when you're buying a CPU. If you ever see anything about lanes and you're very, very dedicated, I guess, toward getting a multi GPU setup like I was, you will run into an issue of efficiency when it comes to this amount right here, which has to do with the lanes. Basically, the CPU directing those PCIe cards and devices on what to do. If we look at, in comparison, the 3960X, which is what I have, and we look right here, it says 88. So way, way more than the other CPU. Before we move into the next component, I want to briefly go over the 3 tiers of CPUs. So I call them tiers, but really there is no better or worse in this department because it all just depends on what you're trying to do. So if we go up here to processors, we'll see, and this is the AMD website. Intel has its own thing, so don't think I'm just doing AMD, but they're a little bit easier to navigate than the Intel website. So if I go here to processors, you'll see there's desktop, laptop, and workstation. These can be kind of interchangeable because a desktop can be a workstation and a workstation can be a desktop. Really, what I'm going to be talking about is specifically the CPU types. So if I go in here, it says AMD processors for this Ryzen series. Okay. So if I go into learn more, these are kind of not this. See, they even put the Threadripper one in here, even though it was separated before. But if we look at these are more of what I'm talking about when it comes to a desktop or a regular consumer processor. And there's no negative connotation there. It's just what it is. It's the standard stuff that people use. And most people never need something like this 16 core 32 uh, thread CPU. I mean, that's crazy for somebody just doing regular word processing and stuff like that. But if we look at it over here, we have an 8 core 16. We have this 4 core one. These are more regular desktop processors, at least these ones here. So whenever someone says, standard consumer or uh, a desktop CPU, that's really what they're talking about. The next sort of tier is the high end desktop tier. And that is where something like the Threadripper processors come in because there's so much more for someone doing like really either hardcore sort of like gaming and enthusiast stuff with their build, and they just want to run benchmarks to be the fastest computer in the world for certain things. But more likely, they're people like me who are content creators who do a lot of 3D renders and video. And that's really where these come in because there's a lot more of those PCIe lanes that I talked about. There's more cores, there's more threads. And overall, the CPUs that are in this category really surpass what most of these can do in terms of the processing speed, the render speed, all that kind of stuff. So it even says right here, do everything all at the same time, render, stream, compile, encode, work and play, all that kind of stuff. So you can still play games on these. It's fine, but if you're a gamer, this is not really where you want to be. If you're a gamer, you want to be over here. So there is a CPU that sort of meets in between, and this is a rather new CPU that meets in between the high end desktop or HEDT CPUs and the standard sort of like desktop CPUs, and that's the 3950X. The reason why I say that is if we go in here to learn more about the 3950X, 16 cores, 32 threads. That's pretty great. I mean, you could not really get this for less than, 1,500, 2,000, or $4,000 just a couple years ago. So this being available to everybody as a in between the really, really expensive, $1,500 plus category, this one should be somewhere around 750 right now. Um, so for I guess if we're comparing it, 9900 KS, 8 thread 16, 8 core 16 thread, and then you have the 3950 that has the 16 core 32 thread. I mean, you're looking at a huge difference in your ability to create with this sort of CPU. And if you look here at the TDP, it's only 105 watts compared to the 127 for the 9900 KS. So you're looking at a much better CPU than a standard desktop, but it's not quite in the high end desktop range. So it meets somewhere right in the middle, and it also happens to have more lanes for your PCIe. It just doesn't show it here for some reason. Let me do a quick search. 3950X PCIe lanes. I believe it has 24. Let's see, 16 plus 4 plus 4. So yeah, it has 24. So that's pretty great. Yeah, 24 lanes. So that's pretty great because that means that you can run more PCIe than you could your other comparable CPU, like the 9900 KS, which only has 16. So again, it meets right in the middle between those two. Oh, look right here. It's only 550. So that's a pretty great deal. Now, if we look at the server CPUs, which I'm not really going to go over very much, basically, these are just really expensive, large CPUs that go into these big bays. for servers. And really, none of you guys need this. I have seen enthusiast builds that do stuff with these. Really don't get into this area. It's really not worth it, and it tends to have a lot of problems. And if you're the kind of person who's building servers, this is not the channel for you. So, just so you guys are aware, that's what these are. They're giant, usually very large and expensive CPUs that go into these big server rooms. The next component we'll be looking at is the CPU cooler. This is the component which keeps your CPU from overheating while you're working, and there really are three mainstream CPU cooler types: the air cooling, closed loop liquid cooling, and open loop liquid cooling systems. The closed loop liquid cooling system is often called an AIO, or all in one liquid cooling system, and we'll just be going over these in a little bit more detail. Air cooling is generally the one of the oldest and the more basic of the cooling systems, and this one's a lot more complex than a lot of the other ones that are out there. And what's really neat is that a lot of these manufacturers of coolers nowadays, and just components in general, they really show you all of the parts of what's going on, and they have these really neat videos that show you all the parts of it. So feel free to go onto the Corsair or other websites that have these cooling components and just take a look at how they're built, and you'll kind of understand how it works. Basically, what you have is you have a plate on the bottom that connects to your CPU, and then the heat pipes go up into this system here, which are basically a bunch of layers of metal called heat sinks, and then it goes to the fan system here that blows the air around to cool your CPU. So again, fairly basic and simple, and it's one of the cheaper options. This one's fairly expensive; it's $100, so that's kind of pricey, and it has this whole enclosure. So you know, um, not sure if this is really worth it. It just was a neat video that kind of showed how all this stuff worked. So not sure if this is the best option for anybody, but it does show very easily here how this whole system is put together. So again, your CPU is connected here, then the heat pipes go up into your the heat sinks that are up here, and then the air gets blown around to cool the processor. So these tend to be a little bit louder, people usually say, but also they can be a lot more efficient at cooling your CPU. So there really is kind of a back and forth between the air cooling and the next cooling system called the AIO, all-in-one closed loop liquid cooling system. But it's worth taking a look at just to know and understand how it works. So feel free to take a look and see how these components all sort of like fit together, and understand sort of like what's going on when you're either selecting a CPU cooler, or if you just want to know a little bit more about this. The next kind of cooler that we'll be looking at is the AIO, or all-in-one closed loop liquid cooler. And basically all this really means, let's do this zoom in here, is that your CPU is being cooled by a radiator and fan system, and then these tubes here have liquid that's being pumped into this part here, where the plate, let me see if they got a photo of it here. Well, the plate is basically underneath this big box, and underneath there is where the CPU is being cooled by. This is actually the other side. So the other part of the other side of this right here is this copper plate. So that is resting on your CPU. Not just resting, there's what's called thermal paste on it, but that doesn't really matter right now. It's connected to your CPU so that the liquid will pump through these tubes into this mechanism here, and then hit that plate to cool the CPU down. And then the liquid is cooled through this radiator and fan system. So whenever you see a tube system coming off of your CPU and connected to something like this, you have a liquid cooled all-in-one system. These tend to be more pricey, but they also tend to be a bit more quiet. And some people say that they're more efficient at cooling CPUs, but really it goes back and forth. There are a lot of arguments and discussions online about which is better, which has more longevity. and which will keep your CPU nice and cool when you're under load. So this is one of those things where really it doesn't matter to me what anybody chooses as long as it works for your system. So especially when you're looking at the large Threadripper uh, CPUs, for some reason, air cooling seems to be the best option for people with the most price options. So it really just depends on what you're looking to do with your build, if noise is a problem for you, and all that kind of stuff. So um, that is the all-in-one. And these come in a lot of different forms. There's 3-fan ones, there's single fan ones, larger, smaller, and some of them are really poorly made. So you really have to be careful on what you're choosing because you really don't want any of that liquid to leak out or for any corrosion to happen inside of your these liquid tubes here. The last type of CPU that I'm going to be discussing is the open loop liquid cooling system. And I'm doing my best to try and find decent photos so that you can see how these work. But if you look online for videos or anything for open loop liquid cooling computers, you'll be able to find a lot of them because when people make them, they like to show them off. And that kind of hits at the heart of what this is to me. Yes, these systems tend to be the best at cooling systems if you're trying to do some extreme overclocking and other stuff like that. And they tend to look really cool. But to me, I really don't care what things look like. I just care if it works. So, just take that into consideration when I'm talking about this. I'm not going to be judging anybody if they have this. If you want to do this, that's fine. It's kind of a feat of engineering that this stuff works the way it does. But basically, what you have is a set of pipes that run from a reservoir of liquid, and this can be a bunch of different colors, into these tubes that cool your GPU system and your CPU. And they run through these water blocks with this running water that's connected to a cooling system. So, and a pump and all this other stuff. So, it's quite a bit of work. It can add hundreds, if not thousands, of dollars to your build. And if it's not done well, it can leak liquid all over your components. And if you don't know anything about electrical, you know, components, you don't want water to be in direct connection with your electronics. So for the purposes of what we're going to be doing in here, you can see the this metal pipe here. I'm looking to see if they have where you could see the actual liquid. Let me see. I have this one here. So this is a really poor image, but again, you can look for a lot. This is from buildgamingcomputers.com. They have a reservoir here, and then they have where you could see the liquid pumping through the system. So if you're the kind of person who's an enthusiast and this is the kind of thing you want to do, fine. Just keep in mind that this is going to add a lot to your price build. And if you're a serious um, content creator, your money is probably best spent on better CPUs or better GPUs or more RAM or a better motherboard or a better case or cooling system or better monitors in many different ways other than this sort of system. So that's really all I'm going to say about this system. If it's what you want to do, fine. Just don't ask me for suggestions because I am never probably going to do this. And I don't have a lot of interest in doing this kind of thing. They are very cool to look at, and they're very neat. They're kind of like little works of art, really, like looking at something like with all these RGB lights and all this other stuff. They're kind of like works of art. Um, but I don't consider a computer really to be that. I consider it more of something that I for utility purposes. So without further ado, let's move on to our next topic. That's going to be it for part one of understanding your computer components. Please stay tuned for part two, where we go into detail on more of the important parts of your computer. Please make sure to hit the like button and subscribe to this channel, and make sure that you hit the little bell to notify you when a new video has been released. And I will see you next time in part two.